Welcome back. So we now start to look at quadratic surfaces. So what are they? Well, these are surfaces that are graphs of the equations of the form ax squared plus by squared plus cz squared plus dxy plus exz plus fyz plus gx plus hy plus jz plus k is equal to 0. Now here, of course, A, B, C, D, E, F, G, H, and J, and K, these are constants. The traces of this graphs in the coordinate planes are all conic sections. So the first quadratic surface that I'm going to be looking at is that of an ellipsoid. The standard equation of an ellipsoid is going to look like this. So this is x squared divided by a squared plus y squared divided by b squared plus z squared divided by c squared is equal to 1. So this is the standard form of the equation of an ellipsoid. So then let's look at an example of that. So let's say I want to know the graph of this equation right here. So this is x squared plus y squared divided by 9 plus z squared divided by 4 is equal to 1. Now to draw this, to see what this surface is, we're going to draw traces. So the first trace I want to get is the trace in the xy plane. So this is the xy trace, meaning this is the trace of the surface in the xy plane. And so the equation for the xy plane is z equals to 0. So to find the trace in this plane, we just plug in 0 for z. And if we do that, we get x squared plus y squared over 9 is equal to 1, which I can write in this way. Now, this is obviously the equation of an ellipse. And so the trace in the xy plane is an ellipse. Also, similarly, if I look at the yz trace, which means that I will plug in 0 for x, we also get an ellipse. And so notice that in my picture, the blue dotted ellipse is the xy trace, and the yellow one is the yz trace. So again, the blue one is the xy trace, the yellow one is the yz trace, and they are ellipses. Now obviously the vertices of the ellipse, the first one is at the point 1, 0, 0, 1, 0, 0 or negative 1, 0, 0. The vertices, the other two vertices of the ellipse would be at 0, 3, 0 and 0, minus 3, 0, which are here and here. Now, obviously, the blue one, these two ellipses, notice that will meet at the points 0, 3, 0 and 0, negative 3, 0. Okay, so again, generally, this is the equation of an ellipse. This is the standard form of an ellipse. Okay, so if you draw these two traces, you obviously see you get a surface which is kind of like a sphere. So this surface is called an ellipsoid, and of course, if I look at the xz trace, that's going to be the gray. That's going to be the gray ellipse, and that's also so that's, if I wanted to, I could have also have drawn this. Now, Okay, so I hope that's clear that why the graph of this guy is an object like this, and so it's kind of like the surface of an egg. The So again, generally the equation of an ellipsoid looks like this. Where A, B, and C are constants. So knowing that's the graph of this equation is an ellipsoid like this, where it has this, let's call that a center. The center of this ellipsoid is at the origin. Now, what would be the graph of this equation? So this equation differs from the first one here, right? It differs in what way? Well, we are subtracting one. We are actually adding 1 to x here. We are subtracting 1 from y and 2 from z, right? So this equation is the same as the previous, except that we are adding 1 to x, we are subtracting 1 from y, and we are subtracting 2 from z. So what's the graph of this equation? Well, the graph of this equation would be also an ellipsoid. So the only difference is the position of the ellipsoid. That is, what you're doing is that you are translating this ellipsoid to the point you're translating this in the x direction by -1 units. In the y direction, you are translating 1 unit in the positive direction, and you are translating this in the positive z direction by 2 units. So if you translate that, this is the ellipse that you get. So the reason is, if you have knowing the points on this one, so anytime you have a point here, point on the graph of this guy, a point on this graph would be found by subtracting 1 from the x coordinate, adding 1 to y coordinate, and adding 2 to the z coordinate. So there you go. So this would be so the graph of this equation would be the same as the graph of this equation, translated by -1 units in the x direction, 1 unit in the y direction, and 2 units in the z direction. Okay, so I think I'm going to end the video here. In the next video, we will look at another quadric surface.